Hey, what's up everybody? I'd like to welcome you to another JUCE tutorial. And in this tutorial, we're going to talk about how to visualize a waveform. So we're going to continue on with our Build a Simple Sampler series. And one of the things, if you've ever worked with a sampler such as Simpler in Ableton, what you normally notice is that when you take a sample and you actually drag it into the plugin window, that it actually displays a waveform of the sample that you're about to play. So we actually did a live stream on this the other day where you saw me kind of squirm and struggle through through actually getting this together. And I'd like to give a big shout out to Mark Spector, who was a very big help in helping me to actually figure out how to do this. So if you want to see how us as developers, we go and we struggle through problems and we think and we try to do workarounds and things like that, then I invite you to check out the 2.5, nearly 3 hour live stream that I did on Saturday. And so it's great because it gives you a more realistic way that you can see how we actually think through problems, and well, at least how I think through them, and times when I get stuck and frustrated and things like that. So yeah, check it out. But we're going to do a fast version of this now that we've figured out how to actually do it. And so we're going to go ahead and get started. Okay, so here we are in our processor where we're actually thinking about loading our file from a data standpoint. And we're in our method that's called load file, where we're actually getting the file from the path, and then we're creating a reader for it, which allows us to actually stream the audio for the actual audio wave. So now the question is, if we think of this audio waveform in terms of values that are going between +1 and -1, and of course if we have more than one channel of audio, so typically we'll have a stereo audio file, we would have two channels of it. And the question becomes, how can we take this data and put it in a place where we can read from it a little bit later to actually display it on our screen? So luckily, we have a method that's actually in our audio format reader class. So we have this format reader that we've created, and we have a method that I had overlooked in my live stream forever, but it's called read. And what we do is we could take in an audio buffer and we can tell it where we want to start from in our reader sample, where we want to start from in the audio buffer, and it will actually put the audio information into the audio buffer. So that sounds pretty convenient, right? Sounds like exactly what we want to do. So we could say mformat reader, read, and now we just need to create an audio buffer. So we'll go to our header file here, and we will create an audio buffer of type float. So an audio buffer is essentially like a vector where we will actually store the waveform. If we were storing more than one channel, then we would it would be like a 2D vector basically. So now we have this audio buffer waveform that we've created. Okay, so as I said before, it's like a vector. Now, our first argument is a pointer to the buffer. So if it's a pointer to the buffer, we need to give the address of the buffer. So that's why I'm using the ampersand operator here to give it the address of the buffer. The start sample and our destination buffer is going to be 0. We want to start from the beginning of the buffer. Number of samples would be, we have this convenient little function here called where we go into the format reader and we can actually get the length in samples. I think it's called, length in samples. Okay, so that's like get number of samples basically. Start sample is 0. And then here we can select if we want to get both the left and the right channel or just the left. We'll just get just the left because we'll just display one channel. and we will do false for the right channel, and there we are. So one thing that you'll notice, so we have a warning here. So what we could do is we could use a static cast and then of type int, and this just will cast our length and samples to an int. So that just gets rid of our warning there. Okay, so one thing that you'll notice if you so one thing that we might want to do here is we might want to iterate through the waveform to actually make sure that it actually has the data from our audio file actually in the waveform. Okay, what you'll find, and I found this in the live stream, is that you need to set the size of the waveform. So the waveform does not have a size at the moment, and if you try to read into the waveform, then it'll either crash or it just won't give you anything in waveform. So what we need to do is we need to do waveform set size, and then the number of channels. Remember, we're just doing the one channel, so it's just one. The number of samples, we'd want to make the number of samples the same as the length of the audio file. So I could just put that here again, where we're getting the length and samples. And now what we could do is we can clean this up a little bit by saying auto sample length equals, and we see how we have this mentioned here twice, right? And it's just this long bit of code, and we could just easily clean that up by just taking that, putting that there, and then putting sample length here. So just giving it a little variable name there, so that just cleans up the code a little bit, makes it a little bit more readable. Okay, so now it's nice and readable. So now let's just go and check and make sure that this actually is reading into the into this waveform audio buffer properly. Okay, so we could use a for loop. So I could say for int sample equals 0, sample is less than waveform get num samples. Then we do plus plus sample. And now what we could do is we would want to get a, remember we could, so we're in an audio buffer. It's not just like a vector, right? It's an audio buffer. We wanted to actually change the information in the audio buffer. We might want to use a right pointer, but since we're actually just reading the samples, we just want to get a read pointer. So I could say auto buffer equals waveform get read pointer. And once again, the channel number we just want is 0 because we just want the first channel. And so now buffer is our pointer into our audio buffer, which is like a vector. So now I can say, I can just do console out. So we have this dbg, which is like stood C out or stdc out. And what I could do is I could say, I want to find out what the sample is at in this buffer when I drop a wave into, when I drop an audio file onto the sampler. So what this should do is it should read through our entire audio file. It should read through the entire audio file, and it should console out the values between -1 and 1 of the actual audio file. So as we can see, it's consoled out something. So we can see that we have all these values, right? So these are all the values in that wave that I just dropped onto the sampler there. Okay, so that's how we do that. Okay, so we can see that this is properly reading into into our sampler, or not into our, yeah, into our sampler, but also into our audio buffer. So that's great. So now I can just get rid of this now. We know that this is working properly. Okay, so now we can go over to the editor side. And so now what we could do is I will just comment all of this original code out for now. And now we can just kind of pseudocode this out for a moment. So let's just say new file dropped. So has a new file been dropped? Then we can say if yes, then we would say, okay, get the waveform from the processor. And now we have a situation where we need to scale. We need to do some type of scaling. So let's say that our sample is 1 second long. It's 44,100 values. Now, at the moment, our x-axis is 200. I'm going to change it to a little bit more. I'm going to say 600, right? So now our sampler window is 600 wide by 200 on the y-axis. And now we have a situation where we say, okay, so let's just say the sample is equal to 44,100 values, 1 second, right? And then we have this x-axis of our plugin window is 600, right? So what that means is that we're not going to be able to display 44,100 values on a 600 pixel window, are we? So we need to think of a scaling factor here. So a scaling factor that would make sense would be the sample length divided by the size of our window, right? So 44,100, if it was 1 second, divided by 600 will give us some type of number where we'll actually be able to pretty accurately display our sample within our plugin window, right? So here we could say that find ratio, right? And then we have kind of the same situation for the y-axis, where once again we have the values of our audio file are going to be going between -1 and +1, but the size of our y-axis is 200, so we need to actually scale it up, don't we? So we could do size of y window, or y-axis of window is 200. So we need to have something that says, okay, I want -1 to 1 in audio to mean 0 to 200. What we actually mean is 200 to 0, right? Because -1 is going to be down at the bottom, right? Which is going to be where closer to 200 down at the bottom of the window. 1 is going to be closer to 0, which is going to be at the top. Okay, so we need some type of scaling function there. And then we're going to say use the ratio to to take values from the audio buffer and put it in a vector to display. Okay, then draw the waveform. Okay, so that's pretty much what we're looking at. Okay, maybe not quite in that order, but that's the basics of it. So first order of business is get the waveform from the processor. Right, so here we have this M waveform. We can see that it's private in our class. So now we need to give it access. So we could just do a little helper function that will return that actual buffer. So I'm using a reference here because I don't need to make a copy. I just want to find out, I just want to get where our audio buffer waveform is. So get waveform, and then here I can return M waveform. Okay, so now going back to our editor side, we can start filling this in where I can say auto waveform equals processor get waveform, right? So now waveform's a buffer, right? So we've done that. Now, once again, we find this ratio where we say, okay, we want to find the sample length, and then we want to use it, we want to divide it by the x-axis, the number of pixels on the x-axis, and that'll give us this kind of ratio that we could use to display our waveform accurately. So it almost like downsamples it, right? So if you have this audio buffer, it has 44,100 values. We don't need 44,100 values. We just need to go periodically through the audio buffer, pick out values that are going to give us an accurate representation of the waveform itself. So I could say auto ratio equals, and so now remember waveform is now an audio buffer. So I could do waveform get num samples divided by get width, which is the width of our window. And then we have the y-axis, right, where we need to actually scale the values of -1 to 1, and we need to scale it up from 200 to 0, right? So there's a function called JMap, which is like a mapping function, a scaling function, where we can put in our source value. So our source value would be waveform. So actually, I'm sorry. Let's go back a minute here. So we have waveform, and remember we were talking about this ratio where we want to take and we want to pick out samples to put into a vector that where we're not displaying all 44,100 values of our sample. We're just periodically picking them out to give us a pretty general representation of what the waveform looks like. So we need another place where we can actually hold those samples that we're picking out. So natural choice would be a vector, right? So we could say std vector of type float, and I will call this audio points. And now we can say for int sample, so used to type an I there, equals 0, sample is less than waveform, get the number of samples because we want to iterate through the waveform, right? Plus plus sample. And then we want to not go plus plus sample because that's going to iterate through all of the samples in the waveform, right? We want to say sample plus equals ratio, right? Because we don't want to go through every one. We want to go through whatever 44,100 or whatever the value of our number of samples is divided by the width, because that's what's going to give us the ratio. That's going to give us an accurate number where we could go through the whole wave and scale it to the size of our window. So now we can push back. So remember, we have this vector where we're storing our new points where we're going to draw the waveform. So we could say audio points. We have the push back method, which will actually push new values into our vector. And then here we don't have it yet, but essentially we'll be saying buffer at sample index, right? But there's nothing in buffer isn't named yet. So what I could do is I could say auto buffer, because remember, for this waveform, which is an audio buffer, we need to create, if we want to read into the values of an audio buffer, we need to create a read pointer. So we could say waveform get read pointer. We're saying read pointer because we only want read access. We don't need to rewrite the values. And now that error should go away, right? So now I'm going to go back here. I'm going to erase this for a moment. And I'm going to say that we have this JMap, right? Where what we're going to need to do is we're going to need to scale on the y-axis, right? So we've scaled on the x-axis. Right, so we could say here scale audio file to window on x-axis, and now we need to scale on y-axis. Okay, so what do we need to do? What do we need here? We need to iterate through audio points, right? Because audio points is now holding our new values, and what we need to do, so these values are between -1 and +1, and we need to scale them up to 0 and 200, right? So what we could do is we need to go through all the audio points and we need to scale them up. So we say for int sample equals 0, sample is less than audio points dot size plus sample, and then here oops, it's not letting me tab because I need to it's asking me to fill in these values. That's why. So here we go. So I'm going to put that there. And now we're scaling on the y-axis. All right. So here we do not need a right pointer because it's no longer the audio points is a vector. It's not an audio buffer. So now we can say audio points at sample index is what we're actually looking to map, right? So what is the minimum that what's the minimum value that we think is going to be coming through audio points at sample? So the minimum is going to be -1, right? Because these values are going to be between -1 and +1 because it's the audio values, right? Now the target range minimum, we're actually going to make it 200, right? Because when we're at -1, we want it to be down at the bottom. And when it's at the top, we want it to be closer to 0, right? So now it's going to say no matching function call to JMap. That's because we need to tell it what type we want here. So that's why I'm going to use those brackets and say I want float. I want this to be a float. Okay, so now we've done that, right? We've scaled the values from -1 to 1 to mean 200 to 0. Now we've used the ratio to take the values and we've from the audio buffer and put it in the vector to display it. So now we just need to draw the waveform. Okay, so what we need to do is the best way to do this is to use what's called a path. Okay, so path, some of you may be familiar with the path class, some of you may not. So let's have a look here. So path is a really cool class to use. Okay, it's one of those that I need to actually get to learn this class a little bit better. Okay, so I know a bit about it, but I know the basics just to show you the kind of the first steps to getting started with the path class. But the main thing to know about the path class is that what it does is that it takes a number of points and it will draw them all at once. Rather than taking one point and doing it at a time, it will actually it'll store a number of points. So you can actually take, like, for example, here, we'll be able to take all of our points, we'll be able to scale them up, and then we'll actually be able to, at the end of our draw method, our paint method will actually be able to say, okay, take all these points and actually draw them and tell them how we want them to draw. So we start by saying path, and we could just call path P. And now I need to think about how we actually are doing this here. So here we've scaled, and then what we need to do is we will see that JMap actually returns whatever type that so when we do the scaling, each time that it does the scaling is actually going to return a float, right? Here. So what we need to do is we could say auto point equals, okay. So that's where we start there. So now we're going to start this. So now we have this path, we declare it at the very top, and then what we could do is we could say, where do we want to go? So we want to say before our loop, we want to start a new subpath, right? So basically what we want to do is we want to start at the very left of our window, in the middle, right? Because the starting point for the audio file will likely be 0, hopefully. So we could say P, which is our path, start new subpath, and then our starting X is 0, our starting Y, we want it to be in the middle, right? So we could say get height, divided by 2. So this is the same thing as saying, if you were to take a pencil and put it on a piece of paper, where do I want to start? And then I wanted to draw something without picking my pencil back up. Where am I starting the pencil at? And we are starting, in this particular situation, we're starting it from 0 on the x-axis, so all the way at the left, and then we're going halfway up on the y-axis, and that's where we're starting. And now what we want to do is we want to get all these points. We want to scale them. We want to scale them from -1 to 1 to the size of our actual window. And now we want to actually add these to our path. So now we need to do path line 2, I believe is what we want. So we can do P line 2, and then what we would say here is, so our X is going to be sample, because we're actually going from 0 to all of our audio points, right? And then our Y is going to be audio points at sample, right? So this is going to go from sample 0 all the way up to whatever audio points dot size is. So it's going to go 0, 1, 2, 3, 4, blah, blah, blah. And then here we have, this is actually saying, okay, well, what's the value at 0, 1, I say point index, let's say index. So this is the index 0, 1, 2, 3, and so on. Then this is what's the actual value at index 0, 1, 2, 3, and so on. Okay, so that's, and then what it's going to do is it's actually going to draw, oh, I'm sorry, this needs to be, sorry, point. Yeah, because that's what we're doing. We're scaling. Okay, so the way I had it before, this is actually getting the original point, which is going between -1 and 1. What we want is the scaled point. Okay, so when we're actually scaling it from 0 to 200. So that's why I want to point there. Okay, now line 2, what that's going to do is that's going to take a line from the last index. So the very first time it's going to go from where you started, from 0 on the x-axis, in the middle of the screen on the y-axis, and then when we go to index 0, it's going to take a line and it's going to draw it from that first point where you started the subpath to the very first point of your index. And then it's going to do that, and it's going to connect. It's going to connect them. And you can do a lot of different methods that will define how those connect, right? So that could be a tutorial for another day. And then you could use this I think it's fill path. There we go. So stroke path is what we want. And then this is what actually draws it. So at the moment we're doing a line 2 that is actually just connecting the lines, but it hasn't drawn them yet. It actually draws them when we get to stroke path. Stroke path is where we actually do the drawing. Okay, so we do P, and then path stroke type. Let's have a look. Path stroke type is where we could give it like a thickness. We could do like these different joint styles, all different types of stuff. We'll just do a very simple one where we just do the thickness of the line. Path stroke type, and then we want stroke thickness. Let's just make it 2. And that's fine. Okay, so now we have all the colors of black. We do a path, right?
So now we want to set the color to something else other than black so that we can actually see the wave, right? So we do set color. Then we'll do colors white. Cool, but this will call all the time when we're actually, we don't need it to call all the time, do we? We need to figure out when does a file actually get dropped? When do we actually need to redraw this path, right? So we have this files dropped that calls whenever we drop a file on there. We want to make sure that it's a valid file that we're trying to drop. And what we could do is we could say, hey, if we drop a file here, then we want you to call all of this business and redraw our wave, right? So what we could do is we could set a boolean. It could say bool should be painting. We could set that to false. And then what we could say is should be painting here equals true. So what we do is that we set this to true to make sure that all of this business calls to actually repaint our window. And then at the end of it, we could say should be painting equals false. Okay, so what I could do is then I can just take all this, move it in a little bit because we're going to surround this in a method. So if should be painting then now we surround all of this. Okay, I feel like I might have missed something, but let's see where we're at. Okay, so another thing is, okay, if we have something that's already been painted, so if we have a waveform that's already been painted once on there, we need it to clear out anything else, any other stuff before we paint the new waveform, right? So is there clear let's see, there's a method here that I can't remember what it's called. Clear. Oh, it's just p.clear. Sorry. So funny sometimes. Okay, so this should work, I think. So let's see if it works. Okay, got build succeeded. And then here we go, we call our plugin. Okay, here's our new plugin window. So let's see what happens here. Oh, it works. It works. So now let's see if this drops. Okay. But we can see that it isn't properly clearing our path. So it loads once nicely, but when we try to load up another wave, it doesn't load up a second wave. Okay, cool. So let's just have a little think about this. So we need to clear, let's see here. So what if I take path out here, then clear p.clear. Okay. So let's just try that. Okay, I think that's going to clear it right after. Yeah, this is gonna clear it right after I drop it. Essentially, I don't even know if you're actually gonna see it. Oh, no, it worked. No, I'm still getting the same issue. Okay, let's see. Okay, let me think for a second. Oh, you know what? It's not the path that I need to clear. Sorry. It's the audio points that I need to clear. That's what it is. So yeah, because we have M audio points, which is storing our new points, right? So we need to do M audio points dot clear. That clears out all of our vector data. Okay, so here we go again. Got our window. Okay, draws right. There we go. And it's still, yeah, and it still plays just fine. So yeah, so there you go. Redrawable sample window. So we're working our way towards a pro sampler here. So yeah, so I hope you enjoyed this tutorial and you found it helpful. And yeah, it took us a little while to get there, but we finally got there. And I hope you enjoyed it. Be sure to give it a thumbs up, and I will see you next time.